Hello everybody, my name is Christophe Trollet from NNC's company. Welcome aboard for this video presentation about BISS implementation inside our satellite modulator called VYPER. For further details about the BISS standard, please refer to the specific video about the BISS technology. Here today we will see how it is implemented inside VYPER, so it's more a video for the user of the product. In fact, there is two versions of the BISS technology. Version 1, standardized in 2002 with 3 modes, Mode 0, Mode 1 and Mode E. This standard has been updated in 2018, that's the version 2. Version 2 is like version 1 coming with Mode 0, Mode 1, Mode 2, but a 4th mode has been added. Its mode, called CA, CA for conditional access. Very important, BISS version 1 and BISS version 2 are not compatible, so if you are using on one side of the system version 1, you have to use the version 1 on the receiver side, and of course, if you are using version 2, you have to use version 2 on the receiver. It must be the same version of the BISS on both sides of the system. So in the configuration of VYPER, here is the GUI of the product. The first step is to select the BISS version, version 1 or version 2. In the settings, modulation, you've got an encryption chapter where you select the BISS version. Once you have selected the BISS version, you've got the choice of the mode. For the mode 1, you've got choice among mode 0, mode 1, mode E. While when you are selecting version 2, you've got the choice among mode 0, mode 1, mode E and mode CA. For mode 1 and mode E, configuration is very easy and the same as in version 1. So very well known as many of you already used this version 1 since many years now. Today, I'm gonna speak in this video only about the BISS-CA configuration. That's the new mode, a conditional access mode based on the BISS technology, robust, dynamic and flexible. It requires several parameters for the configuration which need to be explained. Here is the block diagram of the BISS-CA feature inside VYPER. I will not go into details, please refer to the specific video about the BISS technology for a full description. It's just to introduce you the different parameters of the BISS-CA configuration. The system is based on 2 encryption keys, the session word, used to control the CISA encryption block, and the session key, used by each receiver to recover the session word. Both keys are changed every X period. It's an adjustable period. So in the GUI, there is one field to set this period. Each key is transmitted as an encrypted data to the receiver in the transport stream. The encrypted session word is transmitted inside the ECM table. So you have to set in the GUI the PID of this ECM table. And the session key is encrypted per receiver using the corresponding public key of the receiver inside the EMM table. So you have to set the PID of the EMM table, provide the list of the public key of the receiver to address with the system, and because this EMM table can be big, you have also to define a bit rate to transmit this EMM table inside the transport stream. That's the main parameters of the BISS-CA function, and now we will see how to configure this process. So once you have selected the BISS version 2 and then the BISS-CA mode, here is the screen. You've got the session ID, it's just an identifier of the session. Here, you have to set the PID of the ECM table, which is used to transport the session word encrypted to the receiver inside the transfer stream. Here, you have to set the PID of the EMM table, which is used to transport the encrypted session key to the receiver inside the transfer stream. Here, you set the random period for the session key and the session word. In our example, it's 10 seconds, but it's adjustable. You can have some minutes and so on. And because I told you that the EMM table can be big, you have also the possibility to select different bitrate to transmit the EMM table inside the transfer stream. Then here you've got two parameters. The first one is seamless file update. That's the way you will move from the current list of receiver to the new one you are about to load on the system. If this parameter is disabled, as soon as you are loading a new list of public key inside the modulator, the new list will be applied. That's a straightforward process. If you enable these parameters, the new list of receiver will be applied once the transmission of the previous list will be finished. So it can take time, but in this case, it's done without any perturbation. Remember, the length of the EMM table depends on the number of receivers you are addressing with the system. So the time required to transmit this table in the transfer stream depends on the number of receivers and the bit rate you have allocated to the transmission of the table. It can be from few seconds to several minutes. With a seamless file update, the process to move from one list of key to another one can take time, but it's done without any perturbation. While if you are disabling this feature, the modification is done quickly, but it can create some service interruption. The second parameter is skip invalid keys. As you have seen, we are providing to the system the list of keys as a CSV file. This file can be corrupted. This file can have some wrong key inside. If you disable the feature, each time you will try to download a CSV file, a list of keys inside the system, each time you have an error, the file will be automatically rejected. If you are enabling this feature, we are just ignoring the invalid key and we are using the rest of the keys which are valid. So here you've got the process just after we load a CSV file into the device. So here you've got the status, you've got the name of the file which is loaded on the device. The green LED is showing that the process is running, everything is okay. You've got the list of keys that we found inside the CSV file and also the list of valid keys that we found inside the CSV file. These two numbers are equal if there is no errors inside the file. But if you have enabled the parameters skip invalid keys, you can have some differences. In any case, if you have some differences, it means that some keys are wrong and the screen displays the wrong keys. Also, you have two buttons. One is to retrieve the list, the CSV file from the modulator to the computer if you want to restore it on your computer. And also, you can have access to the list of the receiver that you are addressing with the current CSV file. Here is the first example of the skip invalid key parameters. In this example, we are loading a file with one error inside, but we disable the skip invalid key parameters. In this case, as you can see on the screen, the file is rejected and we are showing that one key is wrong, and we are giving the position of this wrong key inside the CSV file. Same file that we are downloading on the modulator, but in this case we are activating the skip invalid key parameters. In this case, the file is accepted, the file is not rejected, and as you can see at the bottom of the screen, the number of key used is the number of key that we found minus 1, because one key is wrong, it's the number 17. Also, inside the EMM table, you have the possibility to add a private data section, which is useful to control the behavior of the IRDs. So inside, if you disable this private data, no private data in the EMM table, but if you enable these parameters, you have access to the free parameters of the IRDs. And just to finish, here is the Eurovision example, the Eurovision services, which is using now the BISS-CA feature. So all the IRDs from the members have been upgraded with the BISS-CA feature. Each member is providing its public key to EBU. So there is a kind of database at the Eurovision EBU organization to store all this public key, and per event they are extracting only the public key of the receiver allowed to receive the event. So this list of public key of receiver allowed to receive the content is provided to the uplinker as a CSV file, which is downloaded inside the system. I hope you have enjoyed this explanation about the BISS-CA implementation inside VYPER, and I hope this video will help you to configure the BISS-CA feature. In any case, do not hesitate to contact us. We will be happy to help you to configure your system.